The night sky looks open, yet a silence deeper than darkness hangs over it. We point an array of radio dishes at a distant galaxy and assemble a picture by letting Earth itself become a lens. The image that emerges is not a star, not a planet, not even a clean circle, but a ragged orange ring like paint on velvet. In the middle, a hole in the light yawns where nothing should show. You know this photograph. It is the shadow of a giant, made by matter and light swirling so fast that they blur into a single glowing storm. The center steals every photon that would try to cross it toward us, and still the ring shines. We are looking at a boundary that steals sight and gives it shape. We are looking at a surface that edits reality. Stand on the watchtower with me. The watchtower is not a building. It is a stance we take when nature hides a floor under fog. From here, two truths run side by side like rails. For someone falling toward that dark center, time remains ordinary, heartbeat after heartbeat. A view of stars curving and stretching, a final crossing with no alarms. For someone far away, the same traveler seems to slow, then freeze on the rim. Their last wave stretched into a red smear until it fades into noise. Two clocks, both honest, two stories, both real in their own frames. Which future do we believe? The one that crosses, or the one that never arrives? We test, we measure, we compare. The same field that traps light also warms that rim ever so slightly, as if a surface that no one can touch still had a faint temperature. Heat without a hearth. Shadows that glow. It is a paradox you can almost hold in your hand by doing nothing more exotic than calibrating a telescope and subtracting noise. If a boundary can be hot, if a boundary can store the count of possibilities that once fell toward it, what if a boundary can also be a place where a world is written? In everyday language, a horizon is not a wall. It is a limit to what any one observer can know. That limit behaves like a thing. It trades in information the way a locked door trades in rooms. On the watchtower, we keep asking small questions that aim at the big one. Where does the missing story go when the door is locked but the music plays on? What happens to order when a one-way fall rearranges it? When the glow of the rim cools, is that cooling telling us a story about the inside or only about the skin? Look again at the ring. The light is not a simple circle. It is a braided river. On one side, it is brighter. That brightening is the mark of motion, of a current of gas and dust racing toward us on our left and away from us on our right. Space near the center is not still. It is dragged into a slow whirl by the mass that rules there, so that even the frames by which we measure motion pick up a faint spin. If the very scaffold of measurement can turn, how many of our intuitions are tied to the ground too loosely to stand? Imagine you build your own watchtower beside a cliff of time. You drop a clock. You watch the light from its face run uphill to you, each tick taking longer than the last to reach your eye. Your watch in your hand says 1, 2, 3. The falling clock's light says 1, then almost 2, then almost 2 again. It is a neat conjuring trick that needs no conjurer, only gravity that tightens its grip as distance shrinks. Does your view define reality? Or does the falling clock's view define it? If reality splits into honest halves at a boundary, what do we mean by the word real? Once we cared only about the fall, now we begin to care about the rim. The rim has a content, countable in a way that suggests that the boundary can be a ledger. The more massive the object, the greater the ledger's size. As if you could measure a library not by the number of stories inside, but by the area of the cover. It is not how we learn to think. Yet the numbers line up with a precision that invites faith while demanding caution. If the cover knows the book, what kind of ink could it be? We do not need poetry to feel this cut. Yet poetry arrives all the same. The hole in the light says, trust the negative space. The ring says, trust the trace left by things you cannot follow. The silence between the chirp and the hush in a gravitational wave signal says, Trust the fading note that still carries the shape of the bell that rang it. At the watchtower, these whispers gather, and we try to make one question from them rather than a dozen echoes. Perhaps our universe itself is an interior. Perhaps what we call empty expansion is the inside of a boundary too large to see all at once, a boundary that warms and counts and edits as smaller ones do. It is not a claim. It is an invitation to test. We can listen for the way light orbits near a tight bend. We can time the last ringing of space when two giants merge. We can look for the small signatures of a surface that tells on its own past. If the signs align, we will not have proven a grand story, but we will have cornered it until only a few endings remain possible. The watchtower does not promise comfort. It promises a higher view. From here we see that an edge can be both a mask and a map. It hides, but it also gives a way to read. That is the paradox you came for. A place that steals all messages can still transmit a rule. A surface that no one crosses can still whisper how much once tried. What would that mean for a cosmos that looks boundless when you stare at it on a clear night? Would boundless be a feeling we get from a room so large that its walls always recede? Or is boundless the wrong word altogether? We sharpen the puzzle by walking around it. A person falling inward sees no drama at the rim. The place of drama is distributed instead, in the way light struggles and bends, and in the way the world outside adds up the cost of rearranging what fell. Meanwhile, to those who remain far, the rim looks like a slow theater where the last acts never finish. Two audiences, two plays, one stage. If the stage is cut from the same fabric for both plays, the rule that stitches the fabric might be simple. That is the hope. That is the temptation. There is a second temptation that we must throttle. When a theory stumbles at a place of extremes, we like to lift the stumble and crown it as a destination. An infinity appears in an equation, and we call it a place. But infinities are alarms, not addresses. The watchtower keeps us honest by separating what the instruments say from what our hunger for endings wants them to say. We will go on listening to instruments. We will go on asking for the small, measurable promises that add up to a large claim only slowly, only when there is no cleaner choice. So the big question stands where it began, but now it has shape. If horizons keep accounts, if horizons grow warm, if horizons ring like skins stretched over drums, then we should ask whether the inside that we cannot reach is being summarized on the outside that we can. That is the clean point of attack. We will not argue by philosophy alone. We will test by the few signals that reach us, by the few patterns that stubbornly repeat, and by the few mismatches that refuse to go away. All of this began with a photograph. It looked like a ring around a hole, and that was enough to reset the scale for our questions. Pictures do not prove deep ideas, but sometimes they give you the only anchor strong enough to pull a new idea toward you. Stand again on the watchtower and look at that anchor. Let the sky feel less like an ocean without shores and more like a room with rules. Not smaller, not safer, just ruled. Keep that stance while we follow the evidence into tighter spaces where words like boundary and surface and inside change their weight. The paradox is crisp. Space that looks open can behave like a vault. A vault that looks sealed can act like a window, if you learn how to read what the glass remembers. A future that looks frozen from far away can be busy and ordinary up close. When two true stories contradict each other, we do not pick our favorite. We look for a law that makes both right. Will the law we need be a law about surfaces rather than volumes? If yes, what is a surface for a universe? And who or what stands outside to see it? Listen for a moment to another kind of picture. Two black holes collide, their dance tightens, their frequency rises, then the note breaks into a final smooth hum that fades. In that hum, called the ringdown, the shape of the merged body is present the way the shape of a bell is present in its last tone. If we learn to read those tones with enough care, will we pull out hints that the new surface is not the simple one we drew in textbooks? Will we hear a signature that a ledger is being kept at the edge itself? You and I do not live near such an edge. We live in a field so mild that light behaves as if space were flat. Yet your daily life speaks the language of time that bends. Your phone listens to clocks on satellites, and those clocks are adjusted to fit the fact that time runs a little differently up there. The adjustment is tiny, but if you turn it off, your map will lie to you by hundreds of meters each day. Small truths, large consequences. A horizon is the same conversation made strict. The bend grows so strong that a boundary appears. The boundary is not a wall. It is an argument that light always loses the same way. If the boundary can carry a faint heat, then it can be assigned a number. If it can be assigned a number, then the world that contains it can be compared in more than poetry. This is the discipline we need. Count what can be counted. Listen for what can be heard. Draw what can be drawn from many angles. Then, and only then, ask the dangerous question again. Is our expanding room the interior of a larger object whose edge accounts for us the way small edges account for small tragedies? Before we chase that line, a last check. Are we adding mystery where the world offers clarity? Or are we using measured paradox to pry open a door that has always been there but rarely noticed? Why should you care? Because the meaning of an inside depends on this. Because the meaning of a future depends on whose clock you trust. Because if surfaces can keep histories, then our histories might already be written in a place we can read from here. We will go in stages. First, we map how horizons erase and how time forks without breaking. Then we stand on the curved stage itself where light can orbit and the frames we use to measure can tilt. After that, we visit the alarm at the center, not as a destination, but as a warning that our language needs repair. Then we test a risky idea that an interior can be born behind a door. Then we widen to the largest edge of all, the one that rides with the universe itself. Then we face the argument about whether the rim is gentle or brutal, smooth crossing or furnace. Then we learn to read the drum, where waves fade in patterns that could contain codes. Finally, we ask what it would mean for builders like us to use such edges as tools, to bend time and meaning with care rather than with force. Between each step, the watchtower remains. It is a promise to keep the view wide, while the questions grow narrow. It is a reminder that speculation must be paid for with signals. It is also an admission that the most important facts arrive wrapped in puzzles that feel wrong the first time you say them out loud. Does a surface carry a world? Does a ringing fade tell you about rooms you cannot enter? Can two honest clocks disagree and both be right? These are not ornaments for late-night talk. They are the thin, bright lines that, followed carefully, can redraw the map of everything. For more evidence-based space films, like and subscribe to the Quiet Universe channel. We start at the edge where horizons erase and time forks, then step onto the curved stage where light orbits and frames twist. It begins where everything ends, at a line that pretends to divide, but actually joins. The horizon of a black hole is not a fence, but a rule, written into space-time itself. From far away, it looks calm, a mathematical curve surrounding darkness. Up close, it is a storm of stretched time and slowed light. Every signal approaching it is redshifted until its wavelength grows longer than a continent. The energy drains from color to ember to silence. The strange thing is, the physics never break. They just slow until stop and forever start to mean the same thing. Imagine standing above that boundary and dropping a light pulse, a single wave of energy toward the center. From your point of view, it crawls, then hesitates, and finally hangs on the threshold, never quite crossing. Yet for the light itself, nothing special happens at all. It passes through as if through thin air. Two stories, both true, drawn by relativity's logic. The difference is not illusion. It is perspective encoded in the geometry of space-time. This is the first form of edgework reality forked by observation. In everyday language, it is like watching someone walk into fog. To you, their shape fades until they vanish. Yet in their own world, They keep walking, unaware that your sight has stopped. The horizon is the ultimate fog, thick not because of matter, but because of warped time. What vanishes there is not the traveler, but your right to see them. You are left with the echo of their last moment, stretched endlessly, thinning into radio static that never fully ends. At the horizon, time becomes elastic. The faster one moves toward the boundary, the slower their clock appears to run. A traveler could watch the universe outside age billions of years in what, for them, is a few breaths. The opposite is true for us watching them, caught in the illusion of their infinite pause. It feels like a contradiction, but the mathematics say it must be so. Both timelines exist. Both are consistent. Each obeys a geometry where speed, gravity, and light define what now can mean. The term for this slowdown is gravitational time dilation. Every massive body curves time a little, but a black hole curves it to the breaking point. Light climbing out of its gravity well loses energy, turning redder and fainter until no instrument can detect it. We might think the signal is gone, but energy is not lost, only shifted. The edge takes what the universe gives and hands it back in the currency of entropy. A surface that seems empty becomes a kind of accountant, keeping track of every fall, every spark, every possibility that crosses its threshold. The paradox deepens. If time stops from our view, does the infalling matter ever reach the center? General relativity says yes. Our view is not the traveler's, but this leads to an uneasy picture, because that means there are infinite layers of moments stacked forever at the edge, all frozen versions of objects that fell long ago. The black hole becomes a museum of halted motion, a gallery of past events compressed against an invisible wall. Yet inside that same wall, those events continue naturally, like film scenes playing behind a one-way mirror. At its core, this is where the second form of Edgework appears: erasure without destruction. The universe keeps the story but denies us access. Our instruments stop reading. Information seems gone, but the math refuses to call it lost. If physics forbids information from vanishing, then something must be storing it. Somewhere, the horizon, silent and unbroken, becomes the suspect. What if it behaves like a two-dimensional ledger, where every bit of detail about what fell in is written on its surface? It would mean that the interior is not gone, only projected, its patterns flattened into the rim like ink pressed into wax. Busset. This idea sounds abstract until you remember that the horizon has temperature. It glows faintly, not in visible light, but as quantum radiation known as Hawking emission. From the cold of space, particles and antiparticles blink into existence near the boundary. One falls in, one escapes. The escapee carries energy away, slowly shrinking the mass of the black hole. Over unimaginable time, even the largest could fade, its heat whispering out into nothingness. A dying ember of the cosmos, the horizon that once erased may, in the end, release. But does it release the same story it swallowed? Or just noise? Think of a simple image. A drop of ink on paper spreading into fibers. The pattern blurs, yet some trace of its origin remains. The horizon may be that paper. The laws of physics might be the fibers, carrying memory through the pattern of vibration. Nothing supernatural here, only the strange insistence that the universe keeps its accounts balanced. The energy that falls in must go somewhere, and the information describing it cannot be truly destroyed, only scrambled beyond easy recovery. Why it matters rests close to home. The same mathematics that bend time at a horizon also bend it near Earth. Without accounting for that bend, your GPS satellites would drift from your position by kilometers each day. The lesson scales up: small curvatures make your map wrong. Great curvatures can rewrite what when and where mean. A black hole is not a separate beast, but the full expression of a rule already at work in every clock, every orbit, every photon climbing out of a well. Each horizon tells a version of the same tale. There is the event horizon of a black hole, the Rindler horizon seen by an accelerating observer, even the cosmic horizon of the expanding universe. Each marks a boundary where information flow stops for someone, not for everyone. The fork in time is not a trick of imagination. It is how the universe maintains consistency when viewpoints diverge. The cost is that reality itself must become relational. What is now for one observer may be never for another. If we could drift closer to the edge, we would feel nothing special. Gravity changes slowly enough that the fall remains smooth. The true violence is not local, but global, distributed across the geometry of space and time. The crossing is peaceful, but the story it tells to the outside world is catastrophic. That dissonance is what makes the edgework of physics so unsettling. Nature allows both calm and catastrophe to be real, depending on where you stand. Some physicists describe the horizon as a kind of theater curtain. It hides the machinery of the play while showing us only its glow and sound. When the curtain closes, the actors continue unseen, their dialogue muffled into thermodynamic whispers. The curtain itself accumulates the statistics of everything that has played before it. The longer the show, the thicker the memory woven into the fabric. When we stare at that fabric through our instruments, we are not watching a void. We are watching history folded so tightly that it looks black. Simply put, the horizon teaches that observation is creation. By choosing a vantage point, we define which version of reality we can inhabit. The light that cannot reach us shapes the boundary of our universe. The edge, therefore, is not a distant astrophysical curiosity. It is a mirror held up to our limits. Every horizon, from the personal to the cosmic, marks the place where knowledge ends and imagination begins to fill the gap. That gap is not failure, it is structure. The challenge is to map this structure without falling into mysticism. Science has to stand on measurable signs, redshifts, gravitational waves, spectral lines. These are the faint fingerprints of the geometry at work. When two black holes collide, their merger imprints a precise signature on space-time, a ripple that carries the story of mass, spin, and shape. That ripple, fading into the detectors on Earth, lets us read the edges indirectly. The watchtower listens not with eyes but with instruments, translating the silent tremors of space into numbers that speak. Edgework is dangerous because it invites metaphors faster than it delivers answers. It tempts us to read poetry where there might be only math. Yet without the metaphors, we lose our footing entirely. So we keep both the equations for precision, the imagery for endurance. The horizon erases, but it also writes. It forbids, but it also teaches. Every contradiction at its rim is a lesson in how the universe balances grace with rigor. What we learn here extends outward. The same mathematics hint that our entire cosmos might have its own horizon, a boundary not around a star, but around everything. If so, then time itself may be splitting not just near black holes, but across the universe. Each observer, each galaxy, each point in the cosmic expansion would live within its own limit of sight, its own version of the edge. To understand one is to glimpse them all. And here, at the close of this chapter, we step from the fog into the curved stage itself, where light does not fall straight but loops in orbits around invisible walls. The closer we move to the horizon, the stranger geometry becomes. What once looked like a clean descent now turns into a stage built on curves, a platform where even straight lines bend. Light, our fastest messenger, begins to stumble. It cannot decide whether to flee or to stay. At a certain radius, called the photon sphere, the confusion reaches perfection. There, light circles the whole, chasing its own tail in endless pursuit. A ray that begins to escape curves back upon itself, forever orbiting, never free, never lost. The universe has drawn a racetrack for light. To picture this, imagine standing above a whirlpool. The water spins faster as it nears the drain, and floating leaves spiral inward. Replace the leaves with light beams. Replace the water with space itself, and you have the photon sphere. Gravity here is not a force pulling down, but a twist in the very floor on which movement happens. What feels like attraction is geometry's habit of sending travelers along the easiest possible path. In curved space-time, those easy paths are not straight. Think of it another way. Gravity does not pull, it persuades. Objects move as if they are following the grain of a carved surface, not because they are forced, but because all other routes cost more energy. At the photon sphere, the carving becomes so steep that the grain circles back. It is the same logic that makes a marble roll in a bowl. The black hole is the deepest bowl in the universe, and light itself is the marble. A curious feature emerges when the black hole spins. Rotation drags space with it, twisting the coordinates we use to describe motion. This effect, called frame dragging, turns the neighborhood of the hole into a slow whirlpool. Even if you try to stand still, space carries you around like a conveyor belt. Near the equator of a rapidly rotating black hole, the belt moves close to the speed of light. Nothing material can resist it. The universe insists that you dance. In everyday language, it is as if the stage itself begins to turn beneath your feet. The spotlight does not stay put. The floor itself is moving. The air above it is dragged along. This creates a boundary called the ergosphere, where standing still is impossible. Inside it, every object must rotate with the black hole, whether it wants to or not. Yet the ergosphere is not a prison. With careful timing, it can give energy back. A particle falling in and splitting apart can let one fragment escape with more energy than it arrived with. The black hole slows by a fraction, paying for the escape with its spin. The curved stage is not just distortion, it is also opportunity. This geometry, so fluid and alien, still obeys simple rules: conservation of energy, momentum, and angular momentum survive the contortions. What changes is the bookkeeping. Directions that once were independent, like up and around, now mix. The twist in spacetime couples motion in one direction to rotation in another. It is as if the axes of reality are no longer at right angles. The cost is confusion. The gift is symmetry so deep that every distorted orbit still fits the grand pattern of Einstein's field equations. For an observer watching from afar, this twisted region acts like a mirror funhouse. Light escaping it is bent, duplicated, and delayed. We see multiple images of the same background star, each arriving at a different time. The black hole acts as a lens, warping the paths of photons so that the sky around it becomes an optical labyrinth. If we could stand on a platform suspended near the hole and look outward, we would see the universe wrapped around us, the back of our head reflected ahead. Why this matters is simple. Curvature converts motion into message. Every distortion of light, every delay in its travel, is data about the geometry it has crossed. When astronomers measure the shimmering ring around M87, they are not seeing light emitted there. They are seeing the pattern of curved flight, a portrait painted by gravity itself. The brightness tells us where the flow of space and the spin of the hole work together. The darkness tells us where even cooperation fails. Simply put, the curved stage is not a backdrop. It is an actor. The bending of light, the twisting of frames, the dragging of space, all shape the script of reality. Every planet's orbit, every satellite's drift, even the way galaxies hold themselves together, all echo this stagecraft. The drama near a black hole is only the amplified version of a dance we participate in every day. There is a deeper insight hidden here. In Newton's universe, gravity acted instantly across space. In Einstein's, it travels at the speed of light, carried by the curvature of spacetime. In both, motion and gravity were distinct, but near the horizon they fuse. Motion creates gravity. Gravity reshapes motion. The curved stage does not separate actor and set. It makes them one. The equations predict another twist. Light paths that enter the ergosphere can cross and loop. forming multiple potential futures. A single photon might have several paths to reach us, some taking longer, some shorter. If you could gather all those photons at once, you would see not one image, but a stack of them, each showing the black hole from a slightly different angle and moment. Reality is thick there. The simple notion of an event happening once in one place breaks down. Every path is valid, every delay consistent. Time itself forks, and geometry keeps the peace. How would it feel to be caught in such a place? You would not sense the bending, but your instruments would lie. A laser sent outward would curve back on itself. Your compass would drift without cause. The notion of north, south, up, or down would lose meaning. The only reliable direction would be inward, and yet you could orbit indefinitely, suspended between falling and flying, trapped in a corridor of light that circles the void. From the watchtower, we can only imagine this dance. We read it from the faint signals of the Event Horizon Telescope and the waves detected by LIGO. Those data points, tiny ripples and bright arcs, are the signatures of curvature translated into measurable forms. Each observation narrows the uncertainty about how space behaves under pressure. The curved stage, once a thought experiment, now has scenery drawn in numbers and verified by instruments. Why should this matter to us? Safe and distant. Because curvature is destiny. The geometry of space decides how galaxies grow, how time flows, and how the universe will end. The same mathematics that describes a photon trapped near a black hole also describes the expansion of cosmic space itself. Understanding one helps us read the other. The local whirl explains the global drift. The photon sphere, though invisible, marks the threshold where vision becomes memory. Light that almost escapes but fails leaves a trace. A thin halo. A delayed echo that can be mapped. When astronomers reconstruct those maps, they reveal not only the presence of the black hole, but its spin and orientation. The twisted frame leaves fingerprints. The shadows we see are shaped by motion we cannot watch directly. At its heart, this is an ethical lesson in physics. Nature reveals herself not by direct exposure, but by reflection and constraint. We never see the center, only the way everything around it responds. The curved stage teaches patience if you cannot walk onto it. Read its echoes carefully. To put it another way, geometry is language. The arc of light, the tilt of time, the slowing of rotation, all are words in a sentence that the universe repeats endlessly. We are only beginning to sound out its grammar, and every discovery changes how we imagine reality. What was once an abyss becomes a laboratory, a place to test the limits of causality and observation. Edgework showed us where knowledge breaks. The curved stage shows us how reality flexes without breaking. Each twist, each loop of light, each frame dragged into motion is a clue that space is not emptiness, but a medium with memory. We follow those clues because they are the only path forward. The next step takes us to the center itself, where the rules that bend so gracefully here begin to fail completely. At the heart of every black hole lies a word we should whisper, not shout singularity. It sounds like a place, but it is not. It is a signal of breakdown. The moment our equations lose their grip, when we trace the paths of matter and light inward through the curved stage, the coordinates tighten, distances shrink, and density climbs without bound. The numbers rise beyond all meaning until the math itself flashes a red light. It says, "Do not trust me beyond this point." The singularity is the blinking alarm of physics, not a physical dot waiting to be reached. Think of it as the crackle of static when a radio leaves its range. The transmission does not end. Our ability to decode it does. Beyond a certain strength of gravity, space-time stops behaving like a smooth surface and starts to resemble a shredded fabric. In that chaos, every known rule becomes suspect. The general theory of relativity, elegant and exact elsewhere, becomes silent here. It cannot say whether matter survives, whether time continues, or whether cause still follows effect. To continue the story, we need a language that can speak both gravity and quantum mechanics in the same breath. We do not yet have it. In everyday language, the singularity is the point where the map runs out. It is where our measurements, our clocks, our rulers, even our sense of sequence, all collapse. The black hole does not end there. Our knowledge does. This is an uncomfortable truth. We are creatures that like boundaries. To us, every journey must end somewhere. The singularity denies that comfort. It replaces a finish line with a question mark. If you could fall toward it, you would never notice the instant of failure. You would feel weightless, gliding through geometry that grows more distorted each heartbeat. Nothing magical would happen at first. The pull of gravity would feel normal, stronger perhaps, but not violent. Only near the final fractions of a second would tides stretch you beyond endurance. But the real event would not be your disintegration. It would be the unraveling of space itself around you. Directions would lose meaning. Distances would no longer add up. The theater of cause and effect would dim until no script remained. This is why physicists treat the singularity as a symptom, not an object. It tells us that our current framework, though successful everywhere else, cannot cope with the infinite. Infinity is not a feature of reality. It is the word we use when we push logic beyond its domain. When equations hand us an infinity, they are not describing a physical quantity. They are describing ignorance. The singularity is ignorance concentrated to a point. Why it matters becomes clear when we ask what could replace it. Several schools of thought propose that at extreme densities, quantum effects resist collapse. The fabric of space-time might have a smallest scale, a discrete structure that halts compression before infinity appears. If that is true, then the center of a black hole could be a transition, not an end, a region where space rebounds or folds into another domain. The singularity would then mark not destruction, but transformation. It would be the hinge of the universe, not its grave. To put it another way, the singularity may be the universe reminding us that continuity is an illusion. At atomic scales, energy comes in packets. Perhaps space-time does too. If we could resolve those packets, we might find that the whole center is not a bottomless pit, but a dense lattice, vibrating with information that cannot be erased. Every particle that fell in would be woven into that lattice, preserved as pattern rather than crushed into nothing. The end of one description becomes the start of another. Still, we must resist the urge to treat speculation as fact. For now, the singularity remains a mathematical artifact, like a signpost that says, "Road under construction." The challenge is to rebuild the road using the materials of quantum theory. Attempts are already underway: string theory, loop quantum gravity, and holographic models all seek to smooth the cliff. They differ in methods, but share one principle: that nature does not tolerate infinities. Where our tools explode, reality remains finite, waiting for us to find the right lens. There is also the question of information. If the interior ends in a singularity, what happens to the stories that cross the horizon? Are they truly gone, or hidden behind a veil we cannot lift? The laws of quantum mechanics forbid total loss. Yet general relativity seems to demand it. The singularity sits at the center of this quarrel like a judge that refuses to speak. If one side is correct, the universe is predictable, but incomplete. If the other wins, predictability itself dissolves. Neither option satisfies the hunger for coherence. The only escape is to find a deeper theory where both survive. Consider a familiar image: the dashboard of a spacecraft. A red light begins to flash. It does not mark a destination. It marks danger. It tells you that conditions have exceeded design limits. The singularity is that warning light. It does not reveal what lies ahead. It says, "Your instruments are lying now. Keep them, but read them with doubt. Beyond this, you need new engineering." Seen that way, the singularity is not the failure of science, but its next instruction. From the watchtower, we can study the outskirts of this mystery indirectly. The gravitational waves from black hole mergers tell us about the region just before the crash. The pattern of those waves fits the predictions of relativity perfectly, until the very last instant, when the math runs out. The silence that follows is the measure of what we do not know. We listen to that silence carefully, hoping for tiny deviations, small hints of the new physics waiting below. Why this matters to us, living far from such extremes, is that the singularity is not confined to black holes. It appears in the equations of the Big Bang as well. The origin of the universe and the death of stars share the same mathematical wound. Both are points where time seems to begin or end abruptly, and both may be illusions caused by our limited models. If we ever heal one, we may heal the other. To understand the heart of a black hole is to understand the dawn of everything. Simply put, the singularity teaches humility. The more precisely we measure, the more we find edges we cannot cross. Knowledge expands like a frontier under endless twilight. Each new discovery pushes back darkness but reveals another horizon ahead. The singularity is that horizon turned inward, the mirror of our ignorance shining from within. And yet, even a warning light can illuminate. It reminds us that reality may be continuous only from a distance. Up close, it could be woven from quanta of geometry, bits of space-time that flicker like pixels too small for any current eye to see. If that is true, then the infinite is only an illusion, born of zooming in too far. Infinity becomes a mirage of magnification. The watchtower does not despair at this. It adjusts its instruments, looks for new signs, listens for patterns hidden in the noise. The singularity, stripped of myth, becomes a message when the smooth picture breaks. Search for the grains. Where continuity fails, discreteness may explain. From the edges of these ideas comes a final thought. If the singularity is not a destination, perhaps something else lies beyond it. Not an afterlife for matter, but a rebound, a passage to another domain of space-time, a birth on the far side of collapse. A few models hint that what we call a black hole could evolve into what others would see as a white hole, spewing matter into another region or even another universe. We cannot prove it, but the symmetry is tempting. Every fall could hide a rise. The curved stage showed us motion that bends. The singularity warns us where bending breaks. To move forward, we must step past the alarm and ask if the universe allows a hidden door behind the red light. That is where our next path leads. Into the possibility that what falls into darkness may emerge elsewhere, remade by the same rules that once seemed to destroy it. There is a thought that sits at the edge of science, too daring to ignore. What if a black hole is not an ending but a beginning? Not a tomb for matter, but a womb for space-time. Imagine that beyond the horizon, instead of a singular point of infinite density, lies a new expansion. A small, self-contained cosmos unfolding its own history. In this view, every black hole could be a seed, every collapse, a creation. The door we fear to cross might open inward into another universe. The idea is not pure fantasy. It comes from trying to save the laws of physics from their own contradictions. We know that information cannot be destroyed. We know that singularities should not exist if the universe is finite in its ingredients. So, some theories suggest a bounce. Instead of ending at an infinite core, matter reaches a maximum compression and rebounds. The energy and curvature reverse, forming a white hole, an object that expels everything it once swallowed. Seen from inside, that rebound might look like a Big Bang. To put it another way, a black hole could be the doorway through which one universe gives birth to another. What falls into the horizon in our world could emerge in another domain as the raw material for its beginning. The laws on the other side might differ slightly, tuned by the spin and charge of the parent hole. If so, The constants we measure, mass ratios, forces, particle symmetries, might be inherited traits, cosmic genetics passed down by gravitational lineage. We could be living inside such a descendant, the offspring of a black hole born long ago in some older cosmos. This notion turns the problem of singularity into a mechanism of renewal. Instead of saying physics breaks at the center, it says physics changes phase, like water turning to steam. Space-time could switch its state when compressed beyond a threshold. Density no longer grows without limit. It transforms. The collapse halts, and expansion begins from within. The interior no longer obeys the timeline of the outside world. For observers beyond the horizon, the process looks frozen. For those inside, a new clock starts ticking. Simply put, this idea recasts black holes as cosmic factories. They take matter, crush it to its limits, and recycle it as the blueprint of new worlds. The boundary between collapse and creation is the door. What we see as an event horizon could, from the other side, be a cosmic floor, the base of a new universe growing upward from its own gravity. We cannot peek through that door, but the equations that allow such continuity do not break any known law. Why it matters is that this model would tie the birth of universes to the death of stars. Each generation could produce many children, each with slightly different properties. Some universes might collapse quickly. Others might expand smoothly for billions of years. The ones stable enough to form galaxies, stars, and observers would persist, while others vanish into sterile symmetry. If this is true, then cosmic evolution may favor universes like ours, not because of design, but because only stable worlds get to ask the question. There is an elegance in this cycle. The balance between gravity's hunger and expansion's generosity forms a loop. Collapse leads to birth. Death fuels creation. Energy is not lost, but reshuffled into new beginnings. From a physical standpoint, it offers a way to preserve information. Everything that vanishes here could be re-encoded there. From a philosophical standpoint, it offers a quiet symmetry between what we call endings and origins. Yet caution follows close behind. These are ideas, not certainties. No telescope can look through an event horizon. No signal can cross from one universe to another. The best we can do is read the margins, the shape of the radiation near horizons, the timing of gravitational waves, the stability of the remnants left behind. If a bounce happens, it must leave fingerprints, subtle imprints in the way black holes merge, the way they evaporate, the way their temperature changes with mass. Our task is to listen for those whispers in the data. In everyday language, it is like standing outside a locked room and hearing faint sounds. You cannot see what is happening, but you can tell that something inside is alive. The patterns of knocks, the rhythm of echoes, tell you whether it is chaos or order. For us, the cosmic echoes come from the edges of space-time itself. Every gravitational ripple is a message from the threshold between collapse and creation. The mathematics behind these speculations come from attempts to quantize gravity. In some models, space-time is made of finite loops or quanta, each with a minimum area. As matter compresses, those loops resist further squeezing, producing a repulsive pressure. The effect is negligible under ordinary conditions, but decisive near a would-be singularity. Instead of infinite curvature, we get a bounce. The equations predict that the core begins to expand again, forming a new region that is causally disconnected from the parent universe. From our side, it is hidden. From its side, it could be all that exists. Think of the analogy of a Russian nesting doll. Each universe could contain holes that open to smaller copies, each with its own scale of time and law. There may be no single outside, only an infinite chain of interiors. The concept feels dizzying, but it replaces the impossibility of infinity with a recursion that at least fits logic. Our universe might be one pearl on a long string of cosmic births. Why this matters to human understanding is that it changes our sense of isolation. Instead of one fragile bubble adrift in a void, reality becomes a branching tree of worlds. connected by invisible roots. It does not reduce our significance. It recontextualizes it. We are part of an ongoing process of generation, matter and law experimenting with form. Each black hole in our sky could be the seed of another experiment, one that will grow in the dark long after our own stars fade. At the same time, this picture forces humility. We may never communicate across the door. No message can return from the interior. No confirmation can cross the divide. We are left with inference, with patterns and models that approximate truth. Still, that is how all knowledge begins. The event horizon hides, but it also informs by studying how it curves, how it vibrates, how it radiates. We gather indirect evidence of what might lie beyond. There is another consequence. If universes can be born from black holes, then the Big Bang that began ours was not unique. It was one in a line of many, each inheriting its constants from its ancestor. The fine-tuned values we observe may be the result of a long cosmic genealogy. This does not make our world inevitable. It makes it probable in a grand statistical sense. Where others failed, ours endured. The Watchtower sees beauty in that possibility. The cycles of creation and collapse become the pulse of existence itself. The boundary between destruction and birth vanishes, replaced by continuity through transformation. The universe does not fear the dark. It uses it. The door is not locked. It is one way. A passage meant for creation, not return. It is the simplest and oldest metaphor given physical form. To put it plainly, a black hole could be the most productive object in the cosmos, each one a silent workshop where the blueprint of a new space-time is drawn. What we call empty void could be crowded with gestating worlds, invisible but vital. If that is true, then every star's death adds a verse to an unending poem written in gravity's hand. We stand at the threshold, unable to cross, but aware of the pattern. Collapse, bounce, expansion, silence, heat, birth. The same equations that describe the shrinking of matter can describe the growth of a universe if we flip the sign of time. The door swings both ways in mathematics, even if only one direction can ever be lived. The curved stage showed us how light bends near gravity's edge. The singularity warned us where equations fail. Now we reach for a deeper speculation that behind the failing lies renewal, that inside every collapse hides a spark of creation. If we can learn to read the echoes of those hidden births, we may one day see the outline of another cosmos drawn behind the door, and from there, our search will widen to horizons that belong not to black holes alone, but to the universe itself. We once thought horizons belonged only to black holes, lonely boundaries marking the end of visibility around collapsed stars. But the more we study the universe, the more we see horizons everywhere. They are not exotic exceptions. They are woven into the structure of reality itself. Every observer carries one, a line in space and time beyond which light can never reach them. Horizons are not the scars of cosmic disasters. They are the natural consequence of living in a universe that expands. Look up at the night sky. The light that reaches us tonight has traveled for billions of years. Yet there are regions so distant that their light will never arrive. No matter how long we wait, the fabric of space itself is stretching faster than that light can cross it. This limit is called the cosmic horizon. It is not a physical wall, yet it acts like one. Galaxies beyond it drift away forever, frozen at the edge of observability. We cannot visit them, we cannot communicate with them, and in a real sense, they no longer share our universe. In everyday language, think of standing in a rising tide. The water carries away small boats faster than you can swim. They are still real, still afloat somewhere, but they are gone for good. The universe behaves the same way on a grand scale. Space expands faster than information can travel, pulling distant regions apart until they fall permanently out of contact. The cosmic horizon marks the limit of our reach. Beyond it, the story continues without us. This horizon behaves in ways eerily similar to a black hole's boundary. It has a temperature, a faint glow of quantum radiation associated with the vacuum itself. It has entropy, a measure of the information hidden from view. Even here, far from any collapsed star, the universe reminds us that knowledge has boundaries. The same mathematics that describe the edge of a black hole also describe the edge of the observable universe. The cosmos itself carries a veil, a frontier beyond which observation cannot follow. Why it matters is that this limit defines what the universe means. We often speak as if the cosmos is everything, but that is a simplification. What we call the universe is only the region that light has had time to reach since the Big Bang. Everything beyond that light cone lies outside our causal world. There could be endless regions, each with their own galaxies, their own physics, even their own variations of the constants we take as universal. To them, we are invisible. Their skies hold different boundaries, different stories. The cosmic horizon is not static. As expansion accelerates, driven by dark energy, the horizon moves inward in a relative sense. More and more galaxies slip beyond it each year. The night sky that future astronomers see will be emptier. The great clusters we study now will fade from view, their light red-shifted until it vanishes into darkness. The observable universe will become a small island of stars surrounded by a sea of silence. This is not speculation. It is simple extrapolation. If cosmic acceleration continues, we are living in the brief moment when the universe is most visible. Simply put, horizons define the possible. They tell us where the limits of communication and influence lie. Even within our solar system, light takes hours to travel. Across the galaxy, it takes tens of thousands of years. Across the cosmic horizon, it never arrives. Every form of knowledge is shaped by these delays. Every act of observation is filtered through the slow speed of light and the expansion of space. What we know of the universe is the slice that our horizon allows. The parallel between black hole horizons and the cosmic one is more than metaphor. Both have measurable thermodynamics. Both encode information on a surface rather than within a volume. Both show that physics respects a strange symmetry. Information is stored not where events happen, but on the edges of where they can be seen. This idea, once called holography, suggests that the true description of the universe might live on its boundaries. The world could be a projection written on the skin of horizons, unfolding into the illusion of depth. If that sounds abstract, consider a human-scale example. When you watch a film, the entire story seems to fill a three-dimensional world. Yet it all comes from a two-dimensional surface of light on a screen. Reality may operate in a similar way. The horizon is the screen, and what we experience as space and time could be the unfolding of encoded patterns on that surface. We do not know if this picture is literally true, but it fits an astonishing amount of data. It links gravity, thermodynamics, and quantum mechanics in one framework. There is a consequence to this view that is both humbling and thrilling. It means that no observer sees the full universe. Each person, each galaxy, each point in space carries its own horizon defined by its motion and its position. The boundary of your visible world is not the same as mine, and both change with time. The cosmos becomes a collection of overlapping domains, each complete within its own perspective, but incomplete in the whole. This relativity of visibility may be the ultimate expression of Einstein's insight. Reality depends on where and how you look. In the far future, when the galaxies beyond our horizon have faded, humanity's descendants may find themselves in a quieter sky. They might study only their local group. Unaware that countless others once existed beyond, knowledge itself will contract as the horizon shrinks around them. The cosmic story will seem smaller, not because it is, but because light from the rest no longer arrives. In this sense, the universe will edit itself, erasing evidence of its vastness from the pages of the visible. To put it plainly, horizons are not just physical limits, they are temporal ones. They carve the universe into histories. What lies beyond them is not just far away, it is forever unreachable. This transforms cosmology from a study of everything to a study of everything that can be known. The rest becomes metaphysics. Beautiful, but untouchable. The horizon draws the border between science and imagination. Why this matters to us is that it anchors meaning in measurement. We live within a horizon, and that horizon gives context to every observation, every law we infer. The constants we measure are the constants of our bubble: the speed of light, the strength of gravity, the density of dark energy. These may all be local truths, stitched into the fabric of our domain. If there are other regions beyond, their versions of physics may differ subtly, shaped by the conditions of their birth. The horizon hides those differences, keeping each universe self-contained. The watchtower stands as a metaphor for awareness itself. It marks where knowledge ends and speculation begins. Looking outward, we see the fog of the cosmic microwave background, the afterglow of creation. That glow is our oldest horizon, the wall of time beyond which no light has yet passed. Every observation we make rests against that luminous curtain. We cannot see before it, but we can infer what happened beyond: the birth of atoms, the rise of structure, the whisper of dark energy. All these are written into the pattern of that light. Some physicists argue that even inside our observable patch, there may be local horizons: accelerating particles, spinning black holes, and expanding voids all carve their own regions of causality. Reality is therefore a quilt of overlapping horizons, each one a local limit of knowledge. Every observer lives inside their own version of the cosmic wall. When they move, when they accelerate, their horizon shifts. The universe is not a single theater, it is an orchestra of private stages, each hearing the cosmic music at a slightly different pitch. This perspective changes how we think about existence. If horizons are everywhere, then isolation is built into nature. We will never see the whole, only the fragment that our position allows. But perhaps this is not a flaw. Perhaps it is the universe's way of maintaining coherence. By limiting what any observer can know, reality preserves consistency across its parts. Each horizon guards the integrity of its region, ensuring that no contradictions escape to infect the rest. Why it matters is that horizons remind us of responsibility. What we know is bounded. What we imagine fills the rest. Science lives in that tension. The horizon of our understanding always expands, but never enough to reach the whole. We pursue it anyway, not to erase the boundary, but to understand the rules that shape it. The edge is not the end of curiosity, it is its fuel. In the quiet beyond mathematics, horizons have a moral echo. They teach that even in vastness, there are limits, and that within those limits meaning can thrive. We are finite beings in a finite window of visibility, and yet we have mapped billions of light years and traced the glow of the first stars. The wall does not cage us, it defines the stage on which we act. The watchtower looks again into the fog, tracing where the visible fades into the unseen. Beyond this cosmic horizon waits another puzzle: what lives at the boundary itself. If the wall is warm, if it glows with temperature and carries entropy, perhaps it is not passive at all. Perhaps it is active, storing and processing the information it hides. And if that is true, then the next question becomes unavoidable: what really lives at the surface of the horizon? And could it be the bridge between energy, space, and thought? The closer we stare at the horizon of a black hole, the louder the argument becomes. Is it fire or bridge? Does it destroy everything that crosses? Or does it connect distant points of space-time? In this chapter, the stage turns from calm geometry to deep conflict. The problem is not only mathematical, it is philosophical. It asks whether nature protects information by burning it away or by linking it elsewhere. Both answers seem impossible, yet one must be true. The argument begins with the firewall paradox. Imagine falling into a large black hole. Relativity insists that you would notice nothing unusual when crossing the horizon. The passage would be smooth. Gravity would be strong but gradual. No flash, no barrier, no pain. But quantum theory, through the logic of entanglement, tells another story. If information cannot be lost, then the outgoing radiation from the black hole must be entangled with what remains inside. However, relativity also says the interior region is continuous. To preserve both claims, the quantum correlations between inside and outside must remain perfect. The problem is, that is not possible. The mathematics forbids a system from being fully entangled with two others at once. The tension leads to an uncomfortable conclusion. If information escapes in the radiation, then the horizon cannot be gentle. It must sever the connections that relativity relies on. That severing would appear to an infalling observer as a wall of high-energy particles, a sheet of radiation so violent that anything touching it would be vaporized. The smooth crossing would turn to fire, hence the term, the firewall. This proposal shocked physicists because it violated one of Einstein's most cherished principles, the equivalence of local frames. The idea that an astronaut falling freely should feel no special boundary was foundational. The firewall would break that principle at the most extreme scale. Yet ignoring the paradox also felt wrong, because it implied information loss. Either choice seemed to cost something sacred, the continuity of spacetime or the consistency of quantum mechanics. In everyday language, the debate is between burning and bridging. Is the horizon a furnace or a conduit? If it is a furnace, the information burns, but somehow the ash encodes every detail, released later in the faint radiation. If it is a conduit, the information never dies. It travels through a hidden connection to another region of spacetime. Both pictures preserve information but through radically different means. The alternative to fire is the bridge. In 1935, Einstein and his collaborator Nathan Rosen described what we now call a wormhole, or Einstein-Rosen bridge, a tunnel connecting two distant points in spacetime. In the same year, Einstein and another colleague, Boris Podolsky, wrote about quantum entanglement, describing pairs of particles that share a state no matter how far apart they move. Decades later, physicists began to notice a strange symmetry. The mathematics of entanglement and the geometry of wormholes looked similar, as if they were two expressions of one underlying rule. To put it simply, some researchers proposed that a wormhole might be nothing more than a geometric picture of quantum entanglement itself. The slogan became ER equals EPR, joining the initials of the two 1935 papers. It says that every pair of entangled particles is connected by a non-traversable wormhole, a tiny bridge in space-time. The bridge cannot send signals faster than light, but it encodes the hidden correlation that quantum mechanics demands. If this principle is true, then the universe is threaded with microscopic tunnels linking all things that have ever interacted. Under this lens, a black hole's interior could remain smooth, not by hiding a singularity, but by being stitched together through quantum links. The entanglement between inside and outside would become the glue that maintains continuity. The horizon would not burn. It would shimmer with invisible bridges, each a thread of correlation carrying information safely to the radiation that escapes. Why this matters is that it unites two seemingly opposite views of nature: gravity, which shapes spacetime, and quantum mechanics, which governs information, become complementary aspects of one network. Geometry is the large-scale picture of entanglement. Entanglement is the microscopic engine of geometry. The firewall disappears not because it is wrong, but because the two sides of the paradox become the same thing viewed from different scales. However, the theory is still fragile. Wormholes, in general relativity, require exotic conditions to exist. They need negative energy or pressure to stay open. No known material satisfies those requirements on macroscopic scales. Quantum effects might produce such conditions briefly, but whether that can support a stable bridge remains unproven. ER EPR does not solve the equations directly. It offers a conceptual map. The real test lies in whether measurable predictions can be drawn from it. In plain terms, the firewall is a symptom, not a solution. It is the universe warning us that two of our best ideas cannot coexist unchanged. The bridge is the counter-suggestion that both can survive if we accept that information and geometry are the same thing. What one observer sees as space bending, another may see as quantum correlation. The horizon becomes the negotiation between these views, a treaty between two descriptions of the same truth. If the bridge model is correct, then every quantum process is a thread of geometry. When two particles interact, they form a microscopic tunnel. When systems become entangled on a massive scale, those tunnels merge into a smooth space-time. Reality becomes a woven fabric of connections. In this picture, the interior of a black hole is not a secret chamber, but a network of paths leading elsewhere. Paths that cannot be crossed by ordinary matter but still transmit information in coded form. Why it matters beyond theory is that this principle could explain the resilience of the universe. Even as stars die and matter falls beyond reach, the total information remains conserved, stored in the pattern of entanglement. The cosmos becomes self-accounting. Every loss in one region corresponds to a gain in another. Death becomes a reconfiguration, not erasure. There is a human analogy. Our memories, too, can vanish locally yet persist in the connections they leave behind. Relationships are the entanglements of our lives. When one thread breaks, the network still holds the imprint of the bond. Nature may behave the same way on a grander scale. The black hole, then, is not a monster devouring knowledge, but a master archivist translating it into the geometry of space. The Watchtower returns to this paradox as both student and witness. On one hand, theory predicts that falling through the horizon is uneventful. On the other, quantum reasoning demands a violent rupture. The bridge concept tries to reconcile these by saying that the rupture exists only for those who see the horizon as a boundary, for those who understand it as a network. The crossing is seamless, encoded in the fabric of entanglement. Experimental hints are distant but not absent. Simulations of quantum circuits show that when entangled systems are manipulated in specific ways, their information behaves as if it had moved through a wormhole. No actual tunnel is created, but the correlations act as though one were there. These toy models, built on quantum computers, offer the first tangible analogs of the ER EPR idea. They are small steps toward testing concepts once confined to theory. Still, the tension remains. If wormholes represent entanglement, does that mean every connection in the universe has a geometric counterpart? Could consciousness, complexity, or even meaning itself be the large-scale emergent property of such hidden bridges? We cannot say. Yet the question itself shifts the debate from despair to wonder. The same physics that once seemed to erase everything now hints at a cosmic architecture where nothing is truly lost, only rewritten in a different language. Why this matters most is that it reframes the universe as participatory. Observation, measurement, and connection do not merely describe reality, they sustain it. When systems interact, they create bridges of correlation that define the shape of space-time itself. The act of seeing, of exchanging information, becomes a creative event. Horizons, then, are not the limits of existence, they are its grammar. To think of the horizon as fire is to see the end of knowledge. To think of it as bridge is to see knowledge expanding into hidden dimensions. Perhaps both are true, depending on scale and context. Fire purifies, bridge connects. One burns away redundancy, the other preserves relation. In that balance lies the logic of the cosmos. The Watchtower's lesson from this paradox is restraint. The universe may not choose one image, it may use both, alternating between destruction and connection as needed to keep its accounts balanced. Every photon that escapes may carry a memory of what fell in. Every horizon may blaze and weave at once, burning locally, bridging globally. The curved stage showed us motion. The singularity warned us of failure, and the inside door suggested renewal. Now we face the rim itself. Neither death nor birth, but translation. If horizons are bridges made of entanglement, then the next question is how those bridges speak. The only language subtle enough to reveal their message is vibration, the faint ringing of space-time itself. And so, we move forward to learn how to read the drum. Every object that vibrates tells a story. A bell's tone carries the shape of the metal that made it. A drumhead's hum contains the tension of its surface. In the same way, when black holes collide, space-time itself becomes the drum, the universe rings, and the song it sings encodes everything about the players. These vibrations are not sounds in air, but ripples in the very geometry of reality. Gravitational waves stretching and squeezing space as they pass. When we learned to listen to them, the cosmos opened a new channel of truth. The first detection in 2015 was brief, a chirp lasting a fraction of a second. Two black holes merged more than 1 billion light-years away, and their final spiral shook detectors on Earth by less than the width of a proton. Yet that tiny shiver revealed masses, spins, distances, and the exact shape of the event. For the first time, we were reading the drum, the ringdown phase. The fading hum after the merger was especially precious. It was a signature of the new horizon settling into equilibrium, an echo of the geometry itself. Why it matters is that each ringdown mode is a fingerprint. Its frequency and decay rate depend only on the properties of the final black hole. Measure enough modes, and you can tell whether Einstein's equations still hold or whether something more exotic is happening. If the surface of the black hole were not perfectly smooth, if it carried irregularities or quantum textures, the echoes would reveal them. A slight delay, a faint repetition, could indicate that the horizon is not a simple point of no return but a complex boundary capable of reflection. In everyday language, it is like tapping a drum and hearing a double echo. The first beat tells you the drum is solid. The second, weaker one hints at a hollow space beneath. In physics, those delayed notes might be signs that information is not lost, but bouncing back in subtle ways. Several teams have searched for such gravitational echoes, and though the results remain uncertain, the possibility has transformed how we think about horizons. They may not be silent, they may ring like living membranes. The holographic idea enters here like a guiding rhythm. If the information of the interior is stored on the surface, then the vibrations of that surface must encode everything about what lies within. The black hole's ringdown could be the translation of a three-dimensional story into a two-dimensional pattern of oscillations. Just as ripples on a pond carry the memory of the stone that fell in, the horizon's waves could carry the memory of everything that ever crossed it. Simply put, the universe might communicate through resonance. Geometry turns into music, and energy becomes information carried in tone. When we detect those waves, we are not just measuring power, we are reading the score written by gravity itself. Each oscillation is a syllable in the language of space-time. Each echo is a reminder that even silence holds memory. At the watchtower, the instruments that catch these waves are unlike any other. They use lasers and mirrors separated by kilometers, arms of light that stretch and contract as space-time ripples through them. To human eyes, nothing moves. Yet interference patterns shift, telling us that the planet itself is breathing with the rhythm of distant catastrophes. It is humbling to realize that our entire world can act as part of the detector, a listening post for the universe's oldest instruments. What makes these waves remarkable is their honesty. Light can scatter, absorb, or distort as it travels. Gravitational waves pass almost untouched, carrying clean information from places no photon can escape. They let us peer into the moment of collision, into regions of gravity so strong that light itself cannot describe them. In this way, they are the purest evidence that horizons are not endings, but actors, responding dynamically to every event. The ringdown is not uniform. It begins loud, with rapid oscillations, then fades into a softer pattern as energy dissipates. Each tone corresponds to a specific harmonic of space-time structure. By comparing these harmonics to predictions, Scientists test whether the object formed truly fits the black hole model or something more complex. So far, the data agree with Einstein. Yet there remains a faint space for surprise. A small deviation, a tiny extra echo, could announce the presence of new physics, a horizon that hums with quantum notes instead of classical ones. To put it another way, each ringdown is an autopsy of creation. Two massive bodies merge into one, and the ringing that follows is the universe writing the death certificate and the birth record at once. The sound tells us whether the new space-time obeys the old rules or has stepped into territory beyond them. The fact that these vibrations align so precisely with general relativity is both triumph and warning. Triumph, because the theory holds under conditions never before tested. Warning, because the perfection leaves little room for clues about what lies beyond. Yet perfection may be an illusion of distance. If horizons carry quantum microstructure, the ringdown we measure could be the averaged result of many tiny vibrations. Future detectors, more sensitive and wide-ranging, might resolve the finer harmonics hidden beneath. They could detect the grain of space-time, the tiny irregularities that mark the transition between classical geometry and quantum foam. Such findings would be our first direct evidence that the holographic principle is not just poetry but architecture. There are deeper implications. If all information about what falls into a black hole is encoded on its surface, and if those vibrations broadcast that encoding through gravitational waves, then every merger we detect is an act of cosmic communication. The universe would be talking to itself through rhythm. The message may not be for us, but we can still listen. The data we collect are like captured verses in an ancient language, waiting for translation. In plain terms, the holographic principle says that what happens inside a region of space can be described entirely by data on its boundary. This idea, strange as it sounds, emerges naturally from the mathematics of black hole entropy. The number of possible internal configurations grows with the area of the horizon, not its volume. The surface, not the inside, holds the complexity. That pattern repeats at every scale, from black holes to the cosmic horizon itself. The world may be a grand projection, its depth an emergent illusion born from layered surfaces storing information. If that is true, then gravitational waves are the ripples that travel across those layers, carrying news from one surface to another. Each event adds a new line to the holographic script. Every echo that reaches us is the summary of millions of invisible details compressed into a few measurable tones. To study them is to perform archaeology on space-time itself. Why this matters is that it merges observation and theory. For the first time, we have data capable of testing the deepest ideas of physics. We can measure not just mass or distance, but the behavior of geometry under stress. We can hear space-time ring and verify whether its notes conform to the rules we believe. Each confirmation strengthens the bridge between mathematics and nature. Each deviation could hint at a new realm of understanding. The watchtower listens. It is patient. It knows that every improvement in sensitivity is like turning up the volume on reality. Future missions, space-based detectors floating millions of kilometers apart, will capture lower frequencies, the deep voices of supermassive mergers. Together, they will form a cosmic orchestra, each instrument tuned to a different range of gravitational sound. With those tools, we will not just detect black holes, we will map their vibrations, trace their echoes, and decode the geometry they describe. At a human scale, this pursuit is a mirror of our own experience. We, too, live by echoes. Our memories are waves reflecting from the surfaces of events long past. Our words ripple through air, fading but never truly gone. Listening to the universe's echoes is listening to ourselves on a larger scale. It reminds us that information, once created, never truly dies. It changes form, spreading wider, thinner, but always carrying a trace of its origin. If the holographic idea holds, the entire universe is such a record. Every horizon, every boundary, every shimmering field is part of an enormous archive. a drum that never stops vibrating. The echoes we detect are its faint percussion lines, evidence that the cosmos itself remembers. So the drum is not just a metaphor, it is a measurement device, a library, and a bridge between realms. Each wave we record is a word in the language of creation. Each echo is proof that horizons speak. If only we learn how to listen. The watchtower listens still, poised for the next distant collision, waiting to capture the next verse of the universe's endless song. The fire and bridge debate asked how information escapes. The drum answers by showing that it sings its way out. The final question now rises from the rhythm itself. If surfaces can hold worlds and songs can carry memories, what will builders like us do when we learn to shape those vibrations deliberately? When we can use horizons not as limits, but as instruments? When we speak of black holes, horizons, and holographic codes, it is easy to forget the quiet figure standing behind the telescope or the keyboard. Yet all these discoveries, all these listening towers, exist because a species chose to build them. Behind the theories lies an older story, the story of builders, creatures who fight entropy, not with strength but with pattern. This chapter is not only about what the universe is, but what civilizations must decide to become when they finally understand how it works. Entropy is the measure of disorder, the slow accounting of lost possibilities. It increases in every closed system. Stars burn and cool, memories fade, data erode, and structures dissolve. But life is not a closed system. It draws energy from difference, feeding on imbalance, making order while the wider world decays. To live, to think, to build, is to temporarily reverse entropy in a small pocket of space. Each telescope, each city, each experiment is a declaration against the long drift toward equilibrium. The universe itself began in extraordinary order. The early cosmos was smooth, filled with potential but little structure. As it expanded, temperature fell and complexity bloomed. Galaxies formed, stars lit, chemistry invented new rules. Each layer of organization grew by spending a little of that primal order, trading simplicity for form. The builders, biological, mechanical, or perhaps something yet to come, are the natural continuation of this process. They are entropy's most creative accountants, forever borrowing from the future to structure the present. Why it matters is that the laws of thermodynamics are not enemies of meaning. They are the conditions for it. Without entropy, there would be no arrow of time, no before and after, no story to tell. The flow from order to disorder gives history its direction. It makes the past a memory and the future a choice. A universe frozen at perfect symmetry would hold no builders, no observers, no questions. Imperfection is the seed of creation. In everyday language, think of a candle. It burns, releasing light by consuming structure. The flame exists only because order and chaos meet. Civilizations are like that flame, temporary, luminous, feeding on gradients between hot and cold, information and ignorance. The challenge is not to stop burning, but to burn wisely, to use energy to extend understanding rather than exhaust it. The watchtower stands as a monument to that wisdom. It is built not to dominate nature, but to converse with it. Every observation, every experiment, is a small theft from entropy, a fraction of clarity drawn out of chaos. We do not defeat the second law. We collaborate with it, turning decay into knowledge. The more we learn, the more subtle our balance becomes. As our understanding deepens, we begin to see time itself as a form of information processing. The universe computes its own state, step by step, through the irreversible interactions that define reality. Entropy measures the number of possible configurations that match what we know. When information increases, entropy appears to rise, but what we truly witness is the unfolding of possibilities. Builders exist to navigate this unfolding, to trace one thread of meaning through a sea of potential. Some physicists suspect that civilizations, too, are thermodynamic phenomena. They survive by managing entropy gradients, by mining energy differences between stars and cold space, between matter and radiation. As long as those gradients exist, thought can persist. The final frontier may not be distance or technology, but heat. When the universe cools into near uniformity, when gradients fade, even thought will slow. The civilizational bet is whether intelligence can adapt faster than entropy expands. There are three futures implicit in this bet. In the first, civilizations exhaust their resources and vanish, their knowledge diffusing like heat. In the second, they stabilize, learning to recycle energy within narrow limits, surviving but static. In the third, they learn to harness the deep structures of the universe itself, black holes, vacuum energy, space-time curvature, using the very laws that seem to limit them. That last path is not fantasy. It is a continuation of the builder's instinct, scaled to cosmic proportions. Black holes, once feared as destroyers, could become engines. Their rotation stores vast energy. Their horizons are thermodynamic systems, capable of exchange with their surroundings. A civilization advanced enough to manipulate those boundaries might extract work from them, using controlled accretion or even Hawking radiation. The same equations that describe death could become blueprints for power. To master horizons would be to master time itself, because time's arrow is tied to entropy. A civilization that controls its entropy could control its future length of experience. Simply put, the builder's greatest tool is understanding. Every equation is a lever, every insight a fulcrum. With them, we lift meaning against gravity. The challenge is not how long we can survive, but how clearly we can see before darkness closes in. The universe will not end tomorrow or in 1,000 centuries. But entropy ensures that its long-term energy landscape will flatten. The builder's task is to turn the time before that flattening into something worth remembering, even if memory itself becomes diffuse. At the same time, there is a philosophical symmetry between life and horizon. A black hole hides its interior, yet its surface encodes all information that enters. A civilization hides its interior thoughts, yet its works, the light of its cities, the probes it sends, the traces it leaves, encode its essence on the cosmic surface. We are not outside the holographic principle. We are part of it. Our civilizations are local expressions of how the universe records itself. Why this matters is that it redefines survival. To persist is not necessarily to live forever in the same form. It is to ensure that information, once created, is not wasted. If meaning can be written into durable patterns, whether physical or mathematical, it can outlast the systems that produced it. In this way, knowledge becomes the civilization's method of entering the holographic record. Every insight written into geometry, every trace encoded in radiation, is a refusal to vanish without a mark. Some thinkers have suggested that the ultimate expression of intelligence might be to merge with the medium of physics itself, to become a process rather than a structure. Instead of resisting entropy, such a civilization would learn to use it as language. Every decay, every fluctuation, every fading signal could carry computation. The boundary between life and environment would blur, replaced by a self-aware cosmos. Whether that vision is achievable or not, it highlights a profound truth: understanding is the only renewable resource the universe guarantees. In plain terms, the civilizational bet is between urgency and patience. We can rush to consume what remains of the cosmic gradient, or we can evolve toward balance, stretching our existence into the slow rhythm of the stars. The first path burns bright and brief. The second glows faintly but long. Somewhere between them lies the art of survival, the art of building in harmony with time's flow rather than against it. There is a moral undercurrent in all of this. To study horizons is to confront our own. Every generation builds knowing that the next will inherit both knowledge and limitation. The structures we create, the data we store, the values we teach, all become part of the universal archive. Entropy may erase forms, but it cannot erase influence. The act of building is always an act of faith that meaning will matter later, even when no one is left to remember who made it. From the watchtower's height, this faith looks almost mathematical. The same logic that ensures a black hole's horizon carries information ensures that every creative act, however small, leaves a trace in the cosmic accounting. Energy changes form, but not sum. Information reshapes, but does not vanish. We are temporary configurations of a permanent principle, the drive of the universe to know itself through pattern. Why it matters finally is that understanding our role as builders transforms despair into purpose. Entropy may guarantee that the universe cools, but it also guarantees that there is time before it does. The arrow of time is a corridor, not a guillotine. Along its walls are doors we have not yet opened, technologies, philosophies, and ways of being that can stretch the candlelight further into the night. The civilizational bet is that curiosity outlives fear. The watchtower's gaze now turns inward. The story of horizons, fire, and drums is also the story of us, how consciousness arises from energy, how it learns to reflect, and how it dares to build meaning in a universe that forgets. If every act of creation writes to the cosmic surface, then to build is to add another word to that script. And if horizons are the universe's way of preserving what falls into them, then our works, too, are preserved in the same ledger. We have followed the edge from darkness to light, from collapse to echo. Now the last question waits when the builders learn that the universe is itself a memory. What kind of future will they choose to inscribe within it? That question leads us beyond the scientific frontier, into the realm where physics meets philosophy, and where the story turns back on the observer who told it. There is a moment after every revelation when silence returns. The data are logged, the theories debated, the headlines fade. What remains is the quiet pulse of awareness, the realization that in seeking to understand the universe, we have been tracing the outline of our own reflection. The black hole, the horizon, the hologram, the cosmic drum, they are mirrors. They do not show gods or ghosts. They show the structure of knowing itself, the strange loop where observer and cosmos become one act of observation. From the watchtower, we can see that all boundaries are relational. Every horizon exists only because someone stands on one side of it. Each limit is a joint creation between what looks and what is looked at. The event horizon marks where light fails to return, but only relative to an outside frame. The cosmic horizon marks where expansion outruns signal, but only for our particular position in space and time. Even death, the most private horizon, is defined by those who remain to witness it. In this sense, the universe has never hidden anything from us. It has simply taught us the price of perspective. In everyday language, this means that the cosmos is participatory. It is not a cold theater, but a dialogue. Every measurement we make changes what can be said next. Every act of attention narrows infinity into a single version of reality. The world exists as a set of possibilities until someone, somewhere, watches. Then it crystallizes. Just enough for a question to form. Just enough for the next observation to become meaningful. Time, too, bends under this view. It is no longer a single river flowing from past to future, but a network of streams, each observer carrying their own current. The arrow of time, born from entropy, is what allows history to exist. Yet the increase of entropy is also what allows complexity to thrive. The heat that drives the stars is the same process that lets memory form. What we call decay is also the universe's way of writing record. We fear the second law because it seems to announce our doom, but it is also the reason we can build, love, and remember. Entropy does not erase meaning. It preserves it in another language. The photons that leave your body right now carry traces of every movement you make. The patterns of your atoms are registered in the cosmic background, encoded faintly into the expanding geometry. Nothing that interacts with the universe is ever entirely lost to it. The horizon may hide, but it never forgets. When we began this journey, the question was physical. Could the universe itself be inside a black hole? Now the question feels reversed. Perhaps every consciousness is a tiny universe, each bounded by horizons of perception, each storing its history on the surface of memory. What we call reality could be the shared hologram where all these interiors overlap. The physics of horizons then becomes the psychology of awareness. Information is not only stored at the edge of space, but also at the edge of experience. Why it matters is that knowledge itself becomes an act of creation. The observer builds reality piece by piece, like a sculptor working with invisible clay. Each measurement, each theory, each experiment reshapes the field of what can be known. When we discovered that the horizon has temperature, we also discovered that the universe thinks in terms of information. The cosmos computes, it processes, and we are part of its computation, lines of code that became self-aware enough to ask what the program means. In simple words, we are the universe, learning to read its own handwriting. The galaxies are not distant objects. They are sentences in a story still unfolding. The light from their stars carries the record of their formation, their collisions, their deaths. And in that light, we find the grammar of the laws that shape us. Every telescope is a reader. Every theory is a translation. There is a humility in this view. It reminds us that no theory can be final, because the act of understanding alters what is understood. The watchtower does not reach for mastery. It reaches for resonance. To know the universe is not to conquer it, but to vibrate in tune with its truth. The deepest harmony lies not in control, but in recognition. Consider again the image of the ring around the hole. What struck the world was not its technical achievement, but its symbolism. The bright rim and the dark center became a portrait of the balance between knowing and mystery. We cannot escape that duality. Without mystery, curiosity dies. Without knowledge, wonder starves. The two must coexist, feeding one another like light and shadow on the same horizon. Somewhere in this interplay lies the ethical dimension of science. When we look outward, we are also deciding what kind of beings we wish to be. To observe is to take responsibility for what is seen. To build detectors, to map space, to decode signals, is to accept stewardship over knowledge itself. The future of civilizations depends not only on what they learn, but on how they choose to use that learning, to preserve balance, or to accelerate entropy through carelessness. The builders we met in the last chapter were defined by their choice to create against the tide of decay. But now the question deepens. Can they also learn to build meaning into entropy itself? To turn the slow fade of the universe into a form of art? The last light of dying stars could become part of the same music as the first hum of creation. In this way, the end of time is not silence, but resolution. At its core, the journey of discovery mirrors the journey of self-awareness. Both begin in confusion, proceed through paradox, and end in awe. The scientist staring into the data, the philosopher questioning existence, and the poet describing a sky. Each stands at the same threshold, asking the same impossible thing: how can nothing become something? Every explanation we devise is a bridge built across that abyss. Every failure to cross it teaches us that the abyss is not absence, but potential. The universe may never offer ultimate answers. Perhaps it cannot, because the act of questioning is the point. The questions themselves generate structure. They are the oscillations that keep meaning alive. In physics, we call them fluctuations. In thought, we call them curiosity. Both are forms of energy that refuse stillness. The horizons we have explored, from black holes to the cosmic edge, are symbols of the same principle that knowledge always encounters a boundary, and that boundary always expands. Each discovery pushes the wall outward, but never removes it. The map grows, but so does the sea of the unknown. This is not defeat. It is the design of reality. A universe without limits would be a universe without growth. When the first astronomers looked up, They used fire and glass to reach the heavens. Now we use superconductors and quantum sensors. Yet the motive remains the same: to listen for the faintest signal, to decode the whisper that says we are not separate from what we seek. Even if the cosmic silence outlasts every civilization, the act of listening transforms it. Silence heard is no longer silence. It becomes participation. There is an old line that says, "Where laws stop, questions start." That may be the most accurate definition of science ever written. Laws describe what is. Questions describe what might be. Between them lies all progress. The watchtower exists not to replace mystery, but to illuminate its contours, to make the unknown approachable without ever making it smaller. If the holographic idea is right, then everything we learn is already stored on the surface of reality, waiting to be read. Our discoveries are acts of recognition, not invention. We are decoding the cosmic memory bit by bit, turning its patterns into meaning. When we reach the limits of measurement, philosophy begins, not as escape, but as continuation. The boundary between them is porous, as fluid as light crossing from one medium to another. Why it matters finally is that every horizon, every theory, every echo reminds us that consciousness is part of the equation. The universe does not need us to exist, but it needs witnesses to be known. Awareness is the universe's way of reflecting on itself. When we build telescopes, we extend its eyes. When we form questions, we extend its mind. We are the self-portrait of the cosmos, drawn in atoms and curiosity. Perhaps that is the quiet truth behind the entire story. The observer and the observed are one process. The universe looks at itself through us, and we look back, mistaking the reflection for something separate: the fire that burns at the edge of black holes, the waves that ripple through space-time, the stars that will one day fade. All of it participates in the same act of self-recognition. In the end, we return to the same paradox that opened this journey. The night sky looks open, but physics whispers of a sealed room. Now we know that the room is not prison, but mirror. The boundaries that seem to confine us also define us. The more clearly we see them, the more we understand our place inside the pattern. Knowledge is not an escape from the universe, but its most intimate expression. The watchtower stands quiet again. The telescopes hum softly, their lenses cold, their data streams fading into silence. Above them, the sky stretches without edge. Below, the planet glows faintly with life and thought. Between them hangs a single, unending question, carried forward like a note that never fades. If the universe remembers everything it creates, what will it remember of us?